Can you reach full autonomy without a power grid? Would you like to know whether it is worth investing in solar energy? Is it worth to use a buffer battery? Unless you are an idealist, you want to have an estimate of the benefits before you start putting in the effort and spending money on it. Electronics Unmasked gave us a cool Excel tool to simulate sustainable energy production for home use. In the coming episodes, we will calculate very exciting examples that will interest many of you. But first, we need data on solar and wind energy. We will show how to get them for free for any place on Earth. In case you want to get an introduction to the simulation tool and how it works, you can go back to episode EX06, where I'm quickly hovering over all inputs, features and outputs of the tool. In this episode, I will explain the use of a free source to get the inputs for solar and wind energy for every location on Earth. I have already some plans for exciting scenarios to cover in the coming episodes. Now, how's about you? Do you find the topics interesting? Is there any additional scenario you would like to see here? Just start a discussion in the comments. And by the way, don't forget to like the video and subscribe the channel. Let's briefly recap what we are looking for and why. For our predictions and simulations, we need the location-specific yields for solar and wind energy. Of course, it depends on you what you have in mind to use. And then we need the size and orientation of our generators depending on the scenario, which we will define in the later episodes. Now comes the clue. Together with our consumption profiles, we can predict important figures like own consumption, mains consumption and mains feedback during the whole year. Besides a number of analytic functions and performance figures, a very interesting feature is the simulation of a buffer battery, using its state of charge for every hour over the whole year. With that, we can find out the grade of autonomy and the economy of any arbitrary solar and wind generation arrangement on any arbitrary place on Earth. Cool, isn't it? I'm showing now how to derive solar yield data and wind yield data, which you will need for the simulations. I choose the best sources which I could find on the internet. We look at the Global Solar Atlas and the Global Wind Atlas. My credits to the sponsors and the makers of the platforms. First, we open the Global Solar Atlas homepage and we type in the location of our interest. I'm taking Stuttgart in Germany because I have a number of references to compare. The green and yellow colors are indicating that this is not even the greatest place on Earth for solar power. Anyway, solar energy is very popular in this area. By the way, you get also your geographic coordinates in the top section here, in case you don't know them already. Then we scroll down here and choose the type of solar generator which we want to simulate later on. For our example, I'm choosing small residential here. We get a lot more details when we scroll down here. Here is the solar energy yield for the whole year. Roughly 1000 kilowatt hours per kilowatt peak is very much in line with our local experience. Then we click Open Detail. Further down, we get a nice graph for the sun's elevation and azimuth over the whole year. In addition, we see the terrain topography on the horizon on the bottom of the graphic. Remember, for our Excel simulation, we need an angle for the horizon. From this picture, we can derive this angle being about 7 degrees in Stuttgart. Further down, we find the optimum solar panel tilt angle of 37 degrees and the optimum azimuth angle of 180 degrees for our location. And next we find the monthly averages which we need for our simulation. We take notes of the monthly yields here. For January we have 49.5 kilowatt hours per kilowatt peak. For February we have 66.7. For March we have 100.6 and so on. Now let's go to our Excel tool and to the sheet Resources. We type in the monthly average solar yields from the Global Solar Atlas. Remember, they are given in kilowatt hours per kilowatt peak. Because the weather is not reliable in many parts of the world, there will be years of good and bad solar yield. I think in my case here, it is fair to assume a variation of plus and minus 20% in the monthly solar energy yield. If you want to carry out absolute worst case scenarios, you can increase the variation even further. On the right side, we get immediately a graph of our values. Oops, it's showing me that I made a mistake for the value in June. In June, it should be 123.9 kilowatt hours per kilowatt peak instead of 23.9. I need to correct this and it looks much better now. For the wind energy potential, we find something similar as for the solar energy. We open the Global Wind Atlas. We want to have the figures for mean power density. It is also a great information source, and my credits to the sponsors and the makers. We also look for the values in Stuttgart, Germany. The blue color is already indicating that we cannot expect much wind here. We click into the area and some data is appearing on the right side. Let's assume we have a wind turbine which is in 50 meters above ground because the site is on a hill or on a tall building. Okay, then we get this distribution function here, where we can get the mean power density in watts per square meter. We go to the secure side, meaning the power density which we find at 100% of places. In our case, it is 95 watts per square meter. Together with the size of our wind turbine and its efficiency, this gives us an idea of the average nominal power of our wind generation during the year. Of course, it will be only a fraction of this. Then we go to temporal data. We can derive a yearly variation from this. The chart shows us plus and minus 5%. The next chart gives us the monthly average as a wind speed index variation. In January we have a factor of 1.24, February is 1.26, March is 1.1, and so on. For our Excel simulation, we simplify this now a bit. We assume that our wind energy yield is varying in the same percentage. Now 100% yield would be the nominal power, and in our example for January we would get 124% of the nominal power. Okay. We can now insert the average wind power yield as a percentage for each month. As we derived from the wind atlas, we insert 124% for January, 126% for February, 110% for March, and so on. With the graphic on the right side, we can immediately cross-check the plausibility. During summer, the wind energy yield is lower than in winter. This is indeed true for the Stuttgart region. As a variation for different years, we found plus and minus 5%. We calculate the minimum and maximum values accordingly. Of course, we will find the minima and maxima also in the graphic. The insights and the summary. As far as I could compare the values from real existing solar generators in my area, I can say that the estimates for the solar yields derived from the proposed method are pretty accurate. It's hard to give a concrete number for the accuracy here. My guess is plus and minus 5%. Estimating the yield for wind energy appears more difficult to me. The Global Wind Atlas is fine and of great help, similar to the Solar Atlas. However, knowing the efficiency of a wind turbine seems to be difficult. Especially for small wind turbines on low height levels above ground, which we would use for households or off-grid power supply. But at least with our own estimates, we can make up our mind and compare it with the performance figures which a supplier is promising. Electrical energy from water or biogas is dependent from opportunities that we have and from the means that we apply. Okay, now we have the base for our investigations on solar power and wind power for the consumption in households, offices, electrical vehicles, etc. I'm looking forward to the coming episodes where we will have very interesting scenarios to simulate. Now, stay tuned And don't forget to subscribe and support the channel. See you soon in the coming episodes.